So this is our module view of our DMS system. The goal is to test multi-user behavior, race conditions, failure handling and system performance under load. So we implemented custom testing scripts using Python threading and locus to verify ACID properties, atomicity, consistency, isolation and durability. So here let me start the server for our website. So this so now the website server has started. So let me show you the system is running. So this is our system. So let me log in once. So this is our website. So I've successfully logged in as admin. So you can see various tabs. So this shows that our system is running. So this is our front end connected to backend APIs. All operations like member creation, booking, medicine access go through Flask and MySQL. So now let's go to VS Code files. Now this is the file named test seed.json. We use a seeding script to create test users and slots. Now this file stores all IDs like patient IDs, doctor IDs and slot IDs. So all test script reuse this file to ensure consistent and reproducible testing. So this contain doctor ID, sample and patient ID and slot. So we can test. Like for race condition testing, all user target the same slot. So we need this file for testing. Now this is another file named seed test data.py. Now this script logs in as admin, create test users like patient and doctors, inserts slots into database and stores everything in the seed file. So this ensures a controlled environment for testing. Now this is another file for testing concurrency named as test concurrent.py. Now this script simulates multiple users using Python threading. So each thread acts as an independent user sending API request. So all responses are recorded for the later analysis. Now this is like you can see these codes like based on different tests. For test 4 we are testing failure simulation. So this is for the terminal output and different function. And inside this script, multiple threads attempt to book the same doctor slot simultaneously. So this is used to test race conditions where multiple users compete for the same resource. So a different function to test, like for test isolation, for test failure simulation, for test rollback. So this test various multiple things, and this is for the output on the terminal. We also simulate multiple users creating the same username concurrently to ensure duplicates are prevented. So this is for testing multiple things, and there is another file named to test failure and rollback. This is the file. So this script send invalid requests such as missing field or incorrect values, and it counts fail and pass by this check function, and this test unauthenticated function checks an invalid login. Like there are different function named invalid login and test member rollback and test duplicate user rollback. So all this testing code is in this file. So the goal is to verify that invalid operations are rejected and do not affect the database. It also tests duplicate insertion to confirm that failed operation do not leave partial data. Now, this is another file named locust file.py to test on the locus. So this file defines simulated users like admin and patient, each performing API calls repeatedly. So this allows us to test system behavior under continuous load. This for the locust tool. Now there is another file named generate report we have created. This script processes test outputs and generates a structured report summarizing success rates and failures. This is just for our report structure. Now let me run the commands. I've already started the website server. So let me run the first command. Now this is running. Now this is shows that the admin logged in as successfully and this is performing test. Now here we can see that here multiple threads are running in parallel simulating multiple users. So this is the thread output like 15 threads on doctor 6 same slot and same date. So we can see that only one request returns status 201 indicating success while all others return 409 conflicts. So we can see that at most one booking succeeded and rest failed. This happens because once one booking is completed, all others violate the uniqueness constraint. In DB, we enforce this using a unique index on doctor ID, date, and slot. So this concludes that atomicity and isolation only one valid transaction succeeds. Similarly, only one user creation succeed and others fail, preventing duplicates. Also, there is test 3 showing that isolation is performed correctly, like we made one patient to access another patient's portfolio, but it returned status 403, so it passed, so hence isolation is working correctly. Now let's learn the failure and the rollback test file. So now this is running the failure simulation and rollback tests. So here you can see the outputs. Let it run. Now it has completed the test. Now we can see that for every invalid inputs, return proper error codes like 400. So no data is inserted into the database, meaning no partial updates occur. So this ensures consistency and atomicity. Like for invalid login, wrong credentials, it returns 401. For unauthenticated access, all test case pass and returns proper error codes. And for rollback, we can see that when duplicate insertion is attempted, the system rejects it without affecting existing data. So we can see that when we try to duplicate username, so first username with the name got successfully inserted in with error code 201, and when we tried entering duplicate username, so it returned proper 409 error code. So no ghost record after duplicate attempt. So it's ensure duplicate username rollback and also for member creation rollback test. Bad email, missing name, invalid member type, weak password, and member count still remain unchanged after bad insert. So this ensures proper rollback text like no change in the database or fields and other tests like appointment booking rollback, medicine add rollback like when we tried inserting incomplete medicine payload, the medicine count still remain unchanged after bad inserts. So rollback testing is happening correctly and failure simulation also is happening correctly. So these were all the tests. Now to see the load behavior, user load behavior, we can use the tool locust. So I've typed the command this from the locust file.py. It will gen then use the locust tool and then generate the report in the locust report.html, and we will see the report. So let me run that. So now this is running. So we can see that the locust tool is working correctly. It shows that the number of requests happening, fails happening, and an averaged minimum, max, median times each request is taken, and the number of users are increases. Like these are the request numbers. The requests are increasing, and so are the users, and these are the times each request, average, median is taking, and we can see that all the failures are zero. So let it complete first, and then we will see the report in the locus HTML report. Now, as you can see that this report, locus report has been generated, and this is all the locus tool output. So let's see the locus report.html. So this is the report statistics, locus report. Now here this is the generated performance report. So let's see various graph. Like first, these are the request statistics, which shows various type of requests being made to the server, and these average, minimum, max time request take, and we can see that zero failure happened. And this is the response time statistics, 50, 60 percentile statistics. This is the different API called, and we can see failure statistics. No failure was observed on the locus tool, and these are the various charts. Like first, this graph response time, like we can see that this is the response time, and we can see from the this number of users graph that as we increase the number of users to 50 users at the same times on the system, we can see that the response time is stable even under the load. So this is the good sign that our system is behaving correctly, and all requests were successful with zero failure. So as the user increase, system continues to perform correctly. So this shows the system handles concurrent load efficiently without degradation. This can be seen by this locus tool report. Now also for security and isolation, like we can say that unauthorized users receive 401 errors, and role-based access control ensures isolation. So at last, from all experiments, we verified acid properties. Like for atomicity, all operations fully succeed or roll back. For consistency, we saw that invalid inputs are rejected. And for isolation, we saw that concurrent users do not interfere. And at last, durability, we saw that the system handles heavy load and persists data.